All right, so today we're going to be looking at Chapter 10 in this video, and then there'll be a second video that I'll do on Chapter 11. Chapter 10 is on simple interest, and this is basically, if you're going to get a loan or you're going to, make an investment, and you're just getting simple interest on that loan or simple interest on that investment. Then you basically need to just figure out, well, how much interest am I going to pay over the term of that loan, based off of the terms that are given to me. And so it's really simple. That's what we call it, simple interest. It's pretty much a flat interest amount that you will pay. And so, like I said, you may take out a loan or you may invest a short-term investment, and you're wondering, how much interest am I going to earn? And so there's different ways to calculate that interest. And so if you remember, we had the triangular or the circle. I've been using the circle formula that went like this, and we had portion, we had base, and we had rate. And so we're going to use the same formula, very similar to that. However, we're going to change the terms a little bit, and we're going to add one more category, and that other category is time. And so when you're figuring out interest, you can use the same formula. It works exactly the same way, where you have multiplication and you have division. And it helps you to figure out a numerous number of problems that deal with how much interest, how much is the amount of interest, what is the rate of interest, etc., all by using this formula. And this helps kind of solve all of the simple interest problems. And again, simple interest is basically how much money is my money going to earn at a certain rate of interest over a certain period of time. And the only element we're adding here now is time to the factor, or to what we've been working on so far. So if you look at the first one here, this first problem, principal is how much money I'm going to invest. That's what the P stands for. I probably should have wrote that out. And then rate, the R stands for the rate. So that's the interest rate of 8%. And then the time is 2 years. So in this case, what they're asking me is, what would be the interest if I invested or borrowed $5,000 at 8% interest for 2 years? How much interest would I have to pay, or how much interest would I earn? And that's kind of what the kind of problems that you're going to be solving. This all has to do with interest. So in this case, we could just write this problem up as such: 5,000 times 0.08 times, and then the time. Remember, looking at this bottom section of the formula. In this case, 2 years, since 2 years is a whole. And by the way, the time is always in terms of years. So if it's months, it's going to be basically divided by 12 months, because 12 months is 1 year. If it is days, it's going to be basically divided by either 360 days or 365 days. But again, that's how many days are in a year, and I'll explain the difference between the two in a minute. So in this case, I would just do the math on that. I would do 5,000 times 0.8 times 2. And by the way, when you do the calculations for simple interest, you pretty much want to just do it all in one fell swoop on your calculator. So I'm just going to do it right now. 5,000 times 0.08, because that's 8%, times 2 equals 800. So $800 is the amount of interest that my money would either earn or I would have to owe after 2 years at 8%. So that is figuring out interest. So it's pretty simple. The I at the top here represents interest. So if I was to draw up this formula again, I would do 5,000 times 0.08 times 2, and then that would give me my interest of 800. And again, just like all the other formulas that we were working with in this class so far, as long as you have 3 of the factors, you can always solve for the 4th, depending on what it is. And so I'm going to be showing you kind of how to do all that as we move ahead. So we'll just kind of work our way right down this sheet here and solve for each one of these. So this one is solving for the rate. So again, with the same exact problem I just had, if I do a triangle, it's telling me the formula is right here. The rate is 1, or the interest, sorry, 800 divided by the principal times time. So 5,000 times 2. So that would be the same thing as saying 800 divided by 10,000. And if I was to do the math on that, I already know what the rate's going to be because I already did the math on it. But 800 divided by 10,000 equals 0.8, 0.08, or the same thing as 80%. Or yeah, 8%, sorry, not 80. Same thing as 8%. So I'm just doing it each different direction here so that way you can see that this one formula solves it in each different way. So again, the next one, I'm going to solve for principal. So I know the interest, I know the rate, I know the time. So the formula there would basically be interest 800 divided by the rate 0.08 times the time, 2 years. So if I take 08 and I times it by 2, that equals 0.16, and I divide 800 by 0.16. That would equal 5,000, which was my principal amount, right? 5,000. So I'm just, again, doing all of this using the same formula, but different things I'm solving for. So the last one is solving for time, and this is the one that gets a little tricky, and I'll explain this a little bit more later on. But in this case, I'm trying to find time, so I'm going to take, again, my interest earned, which was 800, and I'm going to divide it by the principal, 5,000, times the rate, 0.08. So if I do 5,000 times 0.08, that equals 400. And that would be 800 divided by 400. So 800 divided by 400 equals 2. Okay, so when we're solving for an annual amount of time, it makes it easy. You don't have to do anything. But when we start breaking this down into solving for months, maybe we're only going to invest for 6 months or 18 months. Then we're going to have to do it differently, or days if we go by days. So I'll show you the difference. But here's what you need to know when it comes to time. We can look at it annually. It's always in the terms of annual. So if it's annual, it's just going to be a whole number, 1 or 2. If it's semi-annual, it's going to be 0.5. In that case, 1/2 of a year. If it's going to be quarterly, then you're going to have to put it in terms of 4 divided by 12, because that would be 1 quarter, right? So whatever it is, if it's 3 quarters, then it would be 18 divided by 12, because 3 quarters would be 18 months. And then if it's monthly, you would do whatever the amount of the months are by 12. That's what I just said. And then if you get to daily, depending on your problems, are going to tell you exactly what form you're going to be using. If it's daily, however, you have 2 options. One's 360 days, and this should be 365, or the other is 365 days. Now, what we call ordinary interest is 360 days, and the way that you make it easy to remember is 360 ends with a 0. Well, ordinary starts with an O, and so they're the same. So 360 is always going to be ordinary interest, or ordinary interest is always going to be 360. Exact interest is 365, and that's exactly how many days are in a year. So the exact number of days means 365. The ordinary interest means 360. Now you might say, well, why do we do 360 versus 365? Well, we know that every month, some months are 31 days, and other month, like February, is sometimes 28 or 29 days. So to make it even, banks like to use the ordinary interest method, where they count 30 days of every month, and that's how they do it. So that ends up being 360 days. So they base your interest, or your interest earned or interest paid, off of 360 days, and that's considered 1 year. So just keep that in mind, because the problem is going to ask you, every single one of the simple interest problems will give you, when it deals with days, will tell you using the ordinary interest method or using the exact interest method. And just so you know, ordinary interest method is more common than exact interest method. And this will come when we start drawing up problems on days. So for instance, we could draw the same problem up, instead of doing time in years, we could do it in days. So it would be 5,000 times 0.08, and then times 360. But what's two years at 360 days would be, what is it, 720? So it would be 720 days. For 720 days, the same thing as saying 2 years using ordinary interest. And I would divide that, and I should get the same $800 that I talked about earlier in interest. So that's using what we call the simple interest method. So now we're going to look at it dealing with real problems, or should I say more problems that are more relevant to what we'll be looking at in the book here. So, or what you'll be looking at in your book. So here's a few exercises that we can look at to kind of help solve this. If you notice there, we have an exercise. So we have a principal amount. That's what P stands for. So we have a loan amount that we're going to either take out or invest of $6,440 at a 5.5% rate for 7 months. And so I would just simply draw this up. Again, I can use my formula if I want, and we know that it's, again, principal times rate times time. That's going to give me interest. So if I write that up, it'd be 6,440 times the rate, 0.055, because that's 5.5%, times 7 months. Now, if you go back on the other page I just showed you, if it was in months, it's always in terms of years, so it'd be 7 divided by 12 because there's 12 months in a year. And again, if I do the math on that all in one fell swoop, and I just type it in, 6,440 times 0.055 times 7 divided by 12. And that's what I mean by all one fell swoop. You do it all at once. So I think I need to reset my calculator here. So 6,440 times 0.055 times 7 divided by 12 equals. Hold on just a second. All right, that comes out to $189.71. So that's what we have there. So it's $6,444 at a 5.5% interest comes out to $189.71 of interest that was earned or paid over that. It's only a 5.5 month period, so, or 7 month period. So that was pretty short. Looking at the next one, 32,400.
Professor?
Yeah.
Quick question. On the first one, I ended up getting 205 with 33 cents if like you do it straight through.
You know what I did wrong? Sorry, apologize. Is this should be, I didn't convert the decimal properly, so it should be 0.0505. Try that. See what you get. And you do it all in one fell swoop?
Yes.
Okay.
Let me try to do it with that one though. Okay, 188.53.
Yeah, I converted the decimal wrong. It should be 0.0505 because it's 0.5%. So not
Ended up getting 188.53.
Really? All right, so you wrote down 6,400. Yeah. 6,440 times 0.0505 times 7 divided by 12 equals 189.71. Let's look at the next one. It'll make more sense. So the next one is 0.086 because we converted the percent, and then this is going to be by 241 days using the exact interest method. So what would I put there if it's the exact interest method? What would it be divided by?
365.
365, yep. So let's do the math on that. 32,400 times 0.086 times 241 divided by 365. My whopping total comes out to $1,839.79. Is that what you got? I wrote it all right here. And if I do this other one up here, I get a principal of 100,000 times 0.055 equal or times 18 divided by 12 because it's monthly. So if I do the math on that, 8,000 divided by 0.055 divided by 18 or times 0.055 divided times 18 divided by 12 equals out to $8,250 of interest. And then my last one, 900 times 0.1025 times 60 days using ordinary interest. How many days is ordinary interest?
360.
360. So I do the math on that, it comes out to $15.38. Is that right? Make sure I did that right. Yeah, it's only $900. So 900 times 0.1025 times 60 divided by 360. $15.37.5 or 38 cents. So that's how much interest I earned. So the idea here is we're trying to solve for interest, right? So we are using that formula I already showed you. We're trying to solve for interest. So we're taking the principal times the rate times the time. And we are calculating that, and that gives us our interest right here. So 1538 here, 8250 there, 1839 there. And I think we said this one was 189.71. Okay, follow me so far? It'll get easier as we go, I promise you. All right. I wouldn't worry too much about this, but just keep in mind that obviously once we have the interest, so like if we take the first problem and we take the 6,440, and if we add the interest to that of 189.71, we end up with what we call maturity value, and that is the principal amount I invested plus the interest means that 6440 is now worth almost 66.20 or something like that. If I add those two together, that's how much my money is worth now. So we call that maturity value or future value. So today my present value is $6,440, but at 8% interest, 5.5% interest for 7 months, it's now worth 6,600 and whatever that ends up being, $29, something like that. That's how much that's my future value. So keep in mind, we're always going to be looking, not always, but often be looking for the maturity value, or also known as the future value of that amount. And that means what it's going to be worth in the future. So, all right, this next problem, then we're using the same formula here for all of these. So principal times rate times time, interest. So now what we're trying to solve for is, we're doing the same thing, solving for interest, but this one's going to ask me more questions. So if Michelle Lozano borrowed 5,000, so we'll just write that down, from her credit union for 9% interest, so we're going to do times 0.09 times 80 days. And then it's always going to tell you what form of interest, ordinary interest, so 360. They're going to ask me what was the interest on the loan, what was the maturity value of the loan, and what is the maturity date of the loan. So 80 days, April 12th. So those are the three things that we're solving for. So if I do the math, this 5,000 at 9% for 80 days comes out to $100. So that's my interest. And then it wants to know what is the maturity value of the loan. Well, it would be 5,100, right? Because I'm just adding the $100 to the maturity value, or to the amount of money that I borrowed. And then what's the maturity date? I have 80 days from April 12th. Like I said, get your calendar book out and count the days, but it ends up being July 1st. So that's the answer to that question. Again, this is the simple interest formula. And just make sure you do it all in one swoop, because if you solve the fraction first and then do the math, it won't come out correctly. You got to do it all in one swoop on your calculator. Next question. Emil Benson missed an income tax payment of $9,000. The Internal Revenue Service charges 13%. simple interest penalty calculated by the exact interest method. If the tax was due on April 15th but paid on April 19th, what was the amount of the penalty? So I did the math on that. It comes out to 126 days difference. And we said it was the what form? Exact interest. So 365. So I'm going to do the math on that. It comes out to $403.89. So that was the amount of my penalty. Basically was that 13%. 9,000 was what I owed, and it was a 13% penalty. And so I had to figure out what that penalty would be based off of how many days it was late. It was 126 days late. And so that came out to $403.89 worth of penalty that I had to pay for that. So again, I just used simple interest formula to do it. Are you guys good here? Any questions? Nada? Okay. Let's go ahead and move to the next one then. Open.
I just have one.
Okay.
So from the dates from the April 15 or whatever, whatever dates it said it was due and she paid it or when it was paid, you just add the days from there.
Yeah, basically from April 15th to August 29th or whatever it was, that ended up being 126 days. So
Okay.
how many days late it was. Yeah,
Okay.
I mean, there's this whole thing in your book you can go through and it tells you how to calculate the days, but to me, it's more confusing than it is just to get your calendar book out.
Yeah,
and
it kind of
count
is.
days. Yeah, I'm just being honest because I tried to do it and think I'm going to confuse. We already got enough to figure out. And then I have a student trying to figure out the dates and it's just going to be another confusion. So I thought, just get your calendar out. I haven't even tried to do the formula after that. I just did it on my calendar and that's how I figured out all my answers. So just a lot easier. All right, here's one more. Kyle Roars borrowed $1,080 on June 16th at 9.92%. So that's 092 times. And then how long? Wells Fargo Bank on August 10th. Kyle repaid the loan. On August 10th, he repaid the loan. What was the interest he paid? So again, I got my calendar. I went from June 16th to August 10th. And it came out to be 55 days. And it says, what interest rate am I borrowing? Exact interest. So 365. So they just want to know what was my interest paid. It was $14.97. So again, if I times 1,080 times 0.092, which is the same as 9.2%, times 55, that's how many days there were, divided by 365, because it's exact interest method, it came out to $14.97 of interest. Now, again, you might say, well, then how much did they owe at the end? Well, I had to add that $14.97 to the 1,080, and that would have been what I would have had to total pay in total. All right, so that's solving for interest, and that should be the simplest of them all. You're just multiplying the three items across the bottom on the formula. Now we're going to solve for principal. And the formula for principal looked like this. Principal equals interest divided by rate times time. So that's all I need to do is fill in the factors for that formula. So Telex Electronics borrowed money at 9% interest. So I'm going to do the 09 times the time first for 125 days using the what kind of interest? Ordinary interest right here. So 360. And then ordinary interest method to calculate the amount of principal of the loan. So the interest was 560. So if I'm going to use the formula, I would do 560 divided by the results of this. So if I do 9.9% times 125, 360, let's just do the math on that. I didn't do that yet. So 0.09 times 125 divided by 360 equals 0.03125. By the way, when you are doing these problems, you do want to solve the bottom first. And then I'm going to divide 560 divided by 0.03125, and that equals 17920. So $17,920. So what's that saying is that Tech Electronics borrowed money at 9% interest, 125 days, and the interest was $560. So how much did I actually invest, or how much did I actually borrow? I borrowed $17,920. That was my principal amount, my initial investment. Next question. Tiffany Francis borrowed money from her credit union to buy a car at 13.5%. If the loan was repaid in 2 years and the amount of interest was $2,700, how much did Tiffany borrow? So again, if I'm going to use that formula, interest divided by, this is for principal right here, sorry, rate times time. So I'm going to first figure out my rate. So it's 0.135, that was my rate, times 2, because it was 2 years. So again, it's in terms of years. So in this case, it's 2 years. So I just put 2. I don't have to worry about dividing it by anything. So if I take 0.135 times 2 equals 0.27. So again, my interest was 2,700 using this formula here. And divided by the results, which is 0.27, comes out to 10,000. So my initial investment or purchase of the car was $10,000. Over the course of 2 years, I paid it off, but I ended up also paying another $2,700 in interest. So that kind of sucks, right? So what did I pay total for the car? Would be, I would have to add the 2,700 here, and it would be 12,700. So again, I just used this formula right here for the solving that. So that's for principal. You're just going to solve that by using that formula. Then we get to rate. So again, we remember rate in order to solve that is also interest divided by, but this time principal times time. So I'm going to find my rate by doing those two. So using the ordinary interest method, so I know my time is going to be in terms of 360 days. What is the rate of interest for a loan of 25,000? We'll write it up there, 25,000 times 245 divided by 360, and all of that is divided by 1960, because that's how much interest I paid. Follow me on this so far? All right, so if I do the math on this, I'm just going to rewrite it, 1960 divided by, doing the math on the 25,000 by 345, I didn't do that, so 25,000 times 245 divided by 360 equals 17013.888. I'm just going to keep it 888. Okay, if I divide those two, 1960 divided by 17013. Oops, I messed up. 1960 divided by 17013.888 equals 0.1152, or the same thing as 11.52%. And that's my answer. So my rate for that particular loan of $25,000 for 245 days with an interest amount of $1,960 means I paid an 11.52%, or I earned 11.52% of interest on my money. So again, I just used this formula, which is the same thing as the triangle. Mike Durago took out a loan for $3,500. So we'll write that here. At Gold Coast Bank for 270 days. If the bank uses ordinary interest, 360. What rate of interest was charged if the amount of interest was $269? So I'm just going to write it up like that. Again, this is really the triangle. So if I do the math on that, it's going to be 269 divided by 2625. And if I do the math on that, it comes out to 0.102. I think that was it. So it comes out to 10.2%. That's my answer. So I paid 10.2% interest on that particular loan, or I earned 10.2% interest. So you guys good so far? It's pretty simple. You just use that formula and you can solve all these problems by utilizing that formula. I'm going to go ahead and switch to the next one, which is to solve for time. And when you're dealing with years, as I showed you a minute ago, you don't have to do anything. But when you're dealing with months or days, you're going to have to do one extra step in order to get the correct time. So let's see if that's the one I just did. One more. Let's open this one. It's right here. So now we're going to solve for time. So what is the time period? Again, we're going to use the same loan. So this time we got interest divided by, we're going to solve for time, principal times rate. So if I first find the principal times rate divided by the interest, then that's going to give me the time. But that's not there's one more step in there that I got to show you. So let's first figure out then interest is 650 divided by 15,000 times the rate, 0.095. Okay, if I do the math on that, let me do it first. I didn't do it all. Some of these I didn't do. So 15,000 times 0.095 equals, okay. So it's going to be 650 divided by 1425. If I do the math on that, it comes out to 0.4561404. All right, so that's my answer, but I'm not done because I'm using the ordinary interest method here. I also have to multiply my answer by 360. So if I do 4561404 times 360, my answer is going to be 164.2, or in this case, 165 days. So I solved for days. So you have to, when you're solving for time, you always have to remember to multiply your answer to the formula by what kind of interest rate it was. So in this case, ordinary interest. So I multiplied the answer by 360. That gave me 164.2. I round up because you can't, half a day doesn't count in this scenario. So I have to give you 165 days. That's how many days it was. All right, we'll solve the next one. So Kendall Motors Buick dealership borrowed $225,000 on April 16th to purchase shipment of new cars. If the interest rate was 9.3 using the ordinary interest method, the amount of interest was 960. How many days was the loan and what was the maturity date of the loan? So it's not really asking me for the math on this one. Let's see, did I even do it? I actually did it anyway. So let's go ahead and use the formula. So 9,600 divided by 225,000 times the rate, because we're solving for time. So we know the rate, 0.093. And that came out to 9,600 divided by 20925, which gave me an answer of 0.45878. And because it's which kind of method? Ordinary. I multiply that by 360. And that gave me 165.16 days. Again, you need to round up, so it would be 166 days. So they're asking me though, then what is the maturity date of the loan? How many days was the loan and what was the maturity date of the loan? I didn't even calculate for that, but you would take the date that was given, April 16th, and you would add 166 days to it, and then you have your period. So anyway, I'm not going to worry about it on this problem. I just solved it for the days. All right, so that's pretty much all the ways in which you can solve. You can solve for either interest, you can solve for either the principal amount you invested, you can solve for the rate that you were given, or you can solve for the time, how long the loan was. And all of the problems that deal with simple interest are pretty much going to be around one of those things you're trying to solve. And that's pretty simple. And again, you may want to know these things. If you borrowed money, let's just say you're hoping to have, you got $10,000 now, you're hoping to have $12,000 in 2 years. So what rate would you need to get in order to get that interest? And you can do the calculation and figure out what rate you need to get. Or maybe you can say, well, I only have this rate and I only have this, and I want to gain this much interest. So how much time would I need to invest it at that rate in order to get the money I want? So you can work it all different ways, and it becomes pretty exciting. And again, this is what we call simple interest. There's no compounding. We'll be talking about that next in chapter 11, that compound interest is basically interest that you earn on your interest. So every time you're interest compounds, your principal amount goes up, or your loan amount goes up, or your amount that you've invested goes up, and then the next time that you calculate interest, the interest is taken not only on the original principal but also the interest that it's earned, and so it's going to be a little higher, and that's why it's good for investing with compound interest. It's horrible, like a credit card, to pay using compound interest because you're basically getting charged interest on your interest, and that kind of stinks. So all right, the next thing we're going to cover then is making partial payments, because sometimes you have a loan and it's over a long period of time, and you might say, well, I got money now, I'm going to make a payment now, and then I'm going to make another payment, and then eventually I'm going to pay it off, so that way I don't have this big lump sum at the end. Well, when you do that, you have to figure out how much interest has accrued during the time that you didn't make a payment, and then of course your principal amount's going to be less the next time the interest is accrued. So, for instance, Rita Peterson borrowed $15,000 at 12% ordinary interest for 100 days. But on day 20, she made a partial payment of $4,000. And on day 60, she made another partial payment of $5,000. What is the maturity value of the loan after the partial payment? So they want to know how much on day 100 then will she actually owe. And so because there's interest earned or interest accrued for the first 20 days, so we need to figure out, okay, how much interest did she accrue? So if she originally borrowed $15,000 or invested $15,000 at 12% for 20 days, and it's what form? It is ordinary interest rate, so 360. So this is going to tell me how much interest she accrued for those first 20 days. So if you do the math on that, it comes out to $100, right? Well, if she makes a $4,000 payment, but she's also accrued $100, that means that $3,900 of her payment is going to go towards principal. So if I take the $15,000 that she originally borrowed or invested, and I minus $3,900 for the payment that she made, now her new balance is $12,108. Did I do that right? Hold on. Nope. Her new balance is, I'm looking at the wrong answer down here, is $11,100. So that's the new balance now starting on day 21. However, she makes another partial payment of $4,000 on day 60. So day 21 to day 60 is how many days? Comes out to 40 days. So 1,100 times the same interest rate times 40 days this time. We're going to figure out how much interest she accrued during the next 40 days before she made the next partial payment. So that amount comes out to $148. Well, if she had 11,000, let's see. So then I have to take the 5,000 that she made in a payment minus the $148 comes out to $4,852. So really her $5,000 payment is only $4,852 because she accrued $148 of interest over those next 40 days. So if I take my 11,100 and I minus 4,852 for the payment, I have a new balance now of $6,248.20. However, now that she has that much, she still has how many more days left on her loan? Well, day 60 to day 100 is another 40 days. So we need to take that new balance she has of $6,248.20, multiply it by 12%, and this time another 40 days. That's going to tell me how much more interest she accrued for the next 40 days. It was $83.31. So that's new interest accrued. That needs to be added to her principal that she still owes. So that means at the end of 100 days, she would owe or have earned. In this case, it is a loan, so she's not really investing. It would be $6,331.31. That's how much she owes. That's her maturity value of the loan at the end of the term. That's how much she's going to pay. So does that make sense? You guys follow me on that one? I do have another problem for partial payments. This one's a little easier. So Pamela Boyd borrowed $20,000 at 6.5% ordinary interest for 150 days. On day 30, of the loan, she made a partial payment of $8,000. So what is the new maturity value of the loan? So we need to first figure out how much interest did she accrue for those first 150 days. And if you do the math on that, it comes out to $108.53, but she made an $8,000 payment. So 8,000 minus the 108.53. That means her payment really was only $7,891.67. So if I take the 20,000 and I minus the payment, that means she has a new balance after that payment is made on day 151 of $12,108.33. Now we need to figure, well, then how much more interest is she going to accrue over the next remainder of the loan? And so actually it was the 150 days, so that was day 31. So she still has how many days? If day 31 to day 50 comes out to still another 120 days at 360. So now she has an interest accrued of 262.35. And is it 35 or 33? Do the math. Anyway, that's how much interest. So if I take that amount, let's see. Yeah, comes out to, if I add that together, it comes out to $12,370.68. So I think it was, yeah, it was at 33. Yeah, 33 and 35. So yeah, so 12,370.68 is how much she would owe at the end of the loan on day 150. So just make sure when you're doing partial payments that you figure out how much interest has been accrued over that period of time. All right, so that's pretty much it for chapter 10 when it comes to simple interest. The next thing that we're gonna be looking at is what we call promissory notes. And promissory notes are very similar. What they are, however, is the bank basically takes their interest payment up front. So rather than distributing you the full amount of your loan, let's just say you borrow 5,000, they're going to take their interest out first. So rather than give you 5,000, they're going to basically give you 4,800, depending on how much interest it is, whatever the amount is minus the interest. And so it's a little bit different. We use a little bit different terms. So we use bank discount, basically is the same thing as interest. So it's basically the face value of the promissory note times the rate times time. So it's the same thing as the interest, but they call it a bank discount. That means that's how much the bank is going to discount or take away from the amount that they give you. And then what the amount they give you is what we call proceeds. So the face value of the loan minus the bank discount, that is the proceeds. So that's what they're going to actually distribute to you. So again, if you took out a promissory note at a bank and you went in and you borrowed $5,000 and the interest rate was such that where at the end of that term you would owe $200, then rather than issue you the $5,000 to your bank, when you take out the loan, they're only going to issue you $4,800. Yet over the term of that loan, you will actually pay back $5,000. So they're getting their interest up front. So Aaron Lang has a $20,000 simple discount promissory note at Sovereign Bank for a student loan. The bank is 13% discount rate, and the term of the note is 330 days. What is the amount of bank discount, and what are Aaron's proceeds on the loan? So first thing we want to do is find out what is the bank discount or the interest. So it's really using the same formula we've been using. It's basically, in this case, bank discount. It's going to be face value times rate times time. And it's basically the same exact formula with just different terms. So if we know the face value is 20,000, and we know the rate is 13%, and we know the time is 330 days, and they're telling us, just so you know, they don't tell us what the interest ordinary or exact is. So promissory notes are always 360 days. Now, why do I know that? Because banks always go with ordinary interest, and this is a bank. So you can know that pretty much any promissory note problem is going to be 360 days. So if I do the math on that, it comes out to $2,383 and 33 cents. This is what we call the bank discount, BD. That means that they're going to deduct from the 20,000 when they issue her the loan, the $2,383. So that means if I take the 20,000 that she borrowed minus the bank discount, 2383, that's going to come out to $17,616.67. Those are her proceeds. What that means is that's what the bank actually gave her for her loan. So they took their interest out right up front, and then you're going to be paying it back. So by the time you're done paying it back, she'll have paid exactly $20,000. And that's the difference in a promissory note. Promissory notes are basically saying, I promise I'm going to pay you back the amount you borrowed me within this amount of time. And so the bank just takes their interest out at the beginning. That's the only difference. So again, Boz Foster did a $10,000 simple promissory note, bank discount rate of 6%. The term of the note was 125 days. What was the effective interest rate? So this is the next problem that we're going to be solving right here. And that is the effective interest rate is the bank discount divided by proceeds versus time. So I kind of jumped ahead, but it's the same kind of problem. So the first thing we need to do is figure out what is the bank discount amount. So again, it's the same thing as this is the simple interest problem. 06 times 125 days divided by 360. So this is going to give me my bank discount rate. So in this case, it comes out to, let's see, $208.33. So that's the bank discount. Remember, my bank discount, this is now going to find my effective interest rate. So my bank discount divided by proceeds and time. So proceeds, I have to figure out the proceeds next. So if it was 10,000 and they took out 208.33, then my proceeds are going to be the difference of that, which comes out to $9,791.67. So that's here, $9,791.67. And it's times time. So I'm going to go back and I'm going to go ahead and do 125 divided by 360. So now this is my effective interest rate formula. So if I do the math on that, just to jump ahead, it's going to come out to 208.33 divided by, I'm going to do the math on the bottom first, 3399.8854, etc. If I do the math on that, divide those two together, it comes out to 0.0613, or the same thing as 6.13%. Now you might say, well, what am I solving for here? Well, this is what we call effective interest rate. What that means is, what are you really getting? What interest rate are you really paying? And if you notice, the stated rate was 6%, right? But what did I actually pay based off of this loan? I actually paid 6.13%. So it was a little higher, right? And that's because the effective interest rate is always going to be a little bit higher. It's either you've earned a little bit more or you paid a little bit more. So even though there's a stated rate, when you start calculating interest over time, your rate could actually go up a tad bit. And that's what we're looking at here with the effective interest rate. Now you're going to be solving for effective interest rate on promissory notes. You'll also be solving for effective interest rates on compound interest, because you're getting interest on your interest rate's always going to be, your effective rate, your actual rate is always going to be a little bit higher than the stated rate. And so they want you to figure out what is the effective rate. So we'll look at that when we get to chapter 11. But here's another problem. What is the effective interest rate of a simple discount note of $40,000 at a bank discount rate of 11% for 270 days? So they want to know the effective interest rate. So once again, the first thing we want to do is find out what is the bank discount, because that's the first part of our formula. So 430,000 or 40,000 times 0.11, 11% times 270 days. And again, we always use ordinary interest when it comes to bank discounts. So this one comes out to, did I even do this one? Actually, yeah, no. Yeah, 40,000. Okay, sorry. It's already been done for me. So it comes out to $3,300 That's how much interest there is. So that's going to remain there. Then my 40,000, what is my proceeds? Well, they're going to take that 3,300 off right off the bat. So my proceeds come out to 36,700. So if I use the effective interest rate formula, I'm going to do 36,700 times the time, which was 270 divided by 360. And this math is going to give me the total of, I didn't do it. So actually, let me just rewrite it a different way. Hold on. I'm going to do the math on the bottom. So 36,700 times 270 divided by 360 equals. So the bottom's going to come out to 3,300 divided by 27525. That comes out to 0.11972 or something like that, which is the same thing as saying 11.98%. So again, what did they tell me? I was going to get 11%, but I actually earned almost 12% on that. So my effective rate was actually almost 12% on that particular loan. So that was pretty smoking good. And then we have another problem here. We have this face value. So here's another one, 440 discount rate weeks. So again, we're just trying to find the effective rate. So we take the 50,000, we multiply it by 0.440440, and then times 26 weeks. So that would be by 56. How many weeks are in a year? 56. So I have to do, or 52, sorry, not 56, 52. 52 weeks in a year. So since it's in weeks, I could do it by 52. Do the math on that, it comes out to a $1,100 discount. I'm going to take the 50,000 minus the 1,100 for my proceeds. My proceeds are going to be 48,900. I'm going to use the formula that we've been given for effective interest rate time, which is 26 divided by 52. That comes out to 1,100 divided by 24450, and that equals 0.044989, or the same thing as saying 4.5%. So what did I have? I had 4.4% stated, but I actually earned, my effective rate was 4.5. All right, you guys okay? Is that making sense to you?
So far, so good.
Okay, well, that's pretty much it for chapter 10. Those are the only two things that you need to know, is how to solve for simple interest. And then, of course, how to solve for promissory notes and effective interest rate. And there will be problems like this on both your quiz and your exam, and as well as in your exams coming up as well this week. So there's going to be problems on this on both. And then also your check-in assignment this week. The reason I give you a quiz this week is just to give you a chance to work through these problems. So the goal of that isn't really so much the points, even though you can get up to 12 points. It's really just to let you work through a few problems, and then I'll give you the answers if you get them wrong. And then that way you can kind of see where you went wrong. And then that kind of prepares you to take the exam as well as to do the check-in assignment. So just so you know, that's kind of how I planned it out. So you do have a quiz this week. It seems like a little redundant because you have a quiz and then you have an exam, but just keep in mind, some of the same questions on the exam are from the quiz. So if you master the quiz, you'll do better on the exam, and that's kind of the point. And you can take the quiz up to 3 times, and I'll usually get it graded within 24 hours of when you submit it. So the earlier the better. Then I'll get a chance to give you some feedback, and you can see where you went wrong, or if you get them right, you know you're on the right track. And if you get them right, I don't give you the answer because you got it right. But if you didn't get it right, I'll give you the entire answer broken down in the comments section on the quiz. And that's true of all the quizzes and the exam. I'll give you the answers to the questions if you got them wrong. So, all right, well, that's it for this video. I'm going to move into chapter 11 by starting a new video. So if you have any questions on this, don't hesitate to reach out to me. It's pretty straightforward and simple. I'm just kind of working through the problems in these videos. And hopefully by me doing so, it makes sense. And if something doesn't, make sure you let me know. Or if I did something wrong, because I've already pre-did most of these questions earlier, so I wouldn't have to necessarily redo them live because they take time on the video. But if something went wrong and I didn't catch it, please let me know and I'll fix it. So have a good one, everybody. We'll see you soon. You guys can stay on. I'm gonna just stop the recording.